Okay. I posted homework 5, and I'm going to do something different this year, all right? So this is probably my favorite assignment, but, you know, it's also the students' most popular and least popular assignment. So the assignment is a Monopoly simulation, okay? And it's a very basic Monopoly simulation. We are only simulating board movement for the game Monopoly, okay? So just in case you're not familiar, you know, there's a classic board game called Monopoly, and you start at go and you roll 2 dice and you travel around the board. And as you play the game, you buy and sell properties, and you try to make as much money as you can. And the ultimate goal is to cause all of your friends to lose all of their money, and you be the sole hoarder of all money in the universe. And you know, you revel in your gluttony. That is the goal of the game. It was actually the person who designed the game. Designed it with the intent of promoting, I don't know, kind of socialist ideas and showing that capitalism and greed is bad, and that the only way capitalism will win is that everybody else loses. However, when they when they sold the game, it turned out people had fun playing the greedy capitalist and enjoyed bankrupting their friends and ruining friendships and family relationships at Thanksgiving, and it became super popular. So anyway, that's what we have. If you grew up in America, I'm sure you've played the game. If you didn't grow up in America, this might be a new game to you, and that's fine. The goal is to figure out which properties of the board are landed upon most frequently, okay? Because there are a few quirks in the rules that that change up, you know, which spots get landed on, okay? And so there is a way to do it mathematically and analytically, but it's a little bit complicated. And so probably one of the most common approaches to this problem is via computer simulation. And this is a huge aspect of computational statistics, is being able to write simulations to answer these probability questions about, you know, answer questions about probability without doing the complex math, okay? I think it's fun and rewarding, okay? And in the past, many students have told me that they actually really enjoyed this assignment, and they really enjoyed coding up Monopoly and doing it, okay? At the same time, I also got a lot of feedback from many students saying this was the worst experience of their life. They wanted to, I don't know, do all sorts of terrible things. And now that, and after they completed this assignment, they are now triggered whenever they see the Monopoly game. They used to like the game, and now it brings up, you know, some PTSD. I mean, I don't mean to make light of it, but this is the reality of many programming classes. For some reason, I'm not sure why. I have some theories and ideas why, but when you have like an intro programming course, there's a huge gap in programming abilities. Okay, you go into a differential equations class, sure, there's going to be people with higher and lower ability, but most people are within a fairly tight range of their mathematical ability, right? But in some kind of computer programming class, there's a huge gap, and I think this assignment will appeal to those who are on the higher end of the spectrum who are a little bit more competent in their programming skills. And I think it is, it can feel very overwhelming and nightmarish for those who are, on the other end of the spectrum. And so what I'm going to do this year is I'm going to offer the option to do, there's two homework assignments left. There's this one, the Monopoly assignment, and then after this there's a bootstrapping assignment, okay? So next week I'm going to introduce the topic of randomization tests and bootstrap, and there's going to be a homework assignment related to that. So I want to give everybody the option to choose one or the other, and you'll just be graded on the one you submitted, okay? And that will be that, okay? I don't know. I do want to say, though, if you are thinking of a career in data science, okay, you need to have strong programming fundamentals, okay? This should be an assignment that you can tackle. Writing a tic-tac-toe game should be something you can tackle, okay? I'm just trying to think of other things, like if I said make a game to play Hangman, all right? You should be able to do that, right? Hangman is where there's a secret word, somebody guesses a letter, it will tell you whether that letter's in the word or not, and it will count how many errors you've mistaken and kick you out, all right? That should be a game you should be able to program. You should be able to at least program a 2-player battleship game, okay? And then if you want to do a 1-player where the computer's guessing randomly, that should also be simple. You should be able to program some simple, have the programming skills to do such an assignment. And so, it's not meant to be a challenge, okay? It's good in this moment to have a little bit of self-awareness, okay, and recognize which assignment you might do. The bootstrap assignment is I think still nonetheless interesting, and you may choose to do both, okay. You choose one to submit, okay, and do that. As far as the final exam, topics from bootstrap and randomization tests will of course appear on the final exam, and so I'll release the bootstrap assignment, it'll be due, and then probably I'll post some partial answers for the bootstrap assignment there, but that's what we have. So if you can even start this, and if you decide, okay, this is too much, I don't want to do it, and you change your mind, that's fine, okay? We've got 2 weeks left of lecture and that, okay? And even if your programming skills are good and you're confident, if you take a look at the assignment and you say, I don't want to do this, that's totally fine. That's your choice, your prerogative, okay? I think it's a cool assignment. I had fun writing it. I had fun writing up my solutions for it. Other students have told me as such. But again, many other students have told me it was a terrible experience in their life, and they wish to blot it from their memory. So, everybody's different. Everybody has different preferences. So, yes, question.
What if you do both?
Good for you. No, there's no bonus for that, okay? You can pat yourself on the back and say, I've done myself proud, but I truly want it to be, you have a choice and there's not a penalty for choosing one over the other, okay? We'll just ease that burden off of you guys, okay? Are there any questions about this? The rest of today's lecture, I do want to explain more about this assignment, maybe at least make it a little bit appealing, and at least give you some ideas on how one could approach such an assignment that might feel a tiny bit overwhelming at first, okay? And so we'll spend that, and I do think it's It's worth at least sitting through that. Even if you know right now, after what I've said, you know already, I'm not going to do this assignment. That's fine, okay? You've made up your mind. I'm not going to try to convince you otherwise. But I do want to say, like, there might come a day where you have to approach a big task that can feel overwhelming at first, and we'll talk about how something like this can be broken down, okay? Any other questions? Yes?
Is there any benefit to doing both?
Is there any benefit? Yeah, any time you invest in coding, your coding skill will increase. Okay, that is a great benefit. Okay, are you talking about? Is there any benefit in this class in terms of points? No, there's no benefit for that. Okay, however, again. The goal in your life should not be get points in this class. Okay, the goal the goal in life is much more complicated, but at least as far as your relationship with R and code, you should strive to be as good of a programmer as you can be, okay? And if you are thinking of a career in data science or a career that is going to involve computer programming, then you should have the attitude of trying to get as much experience and as much and honing your skill as much as possible. Okay, I recognize that this is crunch time for all of you, and that's why I'm giving you the option of whether you want to take on this little challenge or not. Okay, I'm not gonna shame you for doing one or the other. Okay, there's no loss for that. Yeah. Okay. Yes.
I'm sorry, I'm a little confused. Are we still going to have a 6 homework assignment, or is this the last?
So you're going to turn in, there's going to be this assignment, and I'm going to release another assignment next week after I start the topic of randomization tests in Bootstrap, okay? And you have a choice of turning in one or the other, okay?
Yeah.
And that's it. Okay, is that all right? Okay, then let's download this RMD template and let's take a look, and then so I got it. Oops, maybe I did. I just deleted that file, but maybe I want that. Okay, so if you do this one, this is how you'll be graded. Okay. So the Monopoly board. Okay, who has never played the game Monopoly? Never? Okay, so I have like 1, 2, like maybe 4 people, but everybody else has played Monopoly? Okay, so we're familiar with the idea of going around the board. We're familiar with the idea of getting sent to jail and drawing chance cards and getting moved around, kind of. Okay. Who has not played Monopoly in the last 10 years? So that would be when you were like younger than 10. Okay, all right, whatever. All right, that's fine. Okay, so most of you are familiar, so I don't know how much of the rules I need to go over. But basically, you're rolling 2 dice, right? And so you can get anywhere from 2 through 12. Obviously, 7 is going to be the most frequent one. Everybody starts on go, and you just travel around in a circle. Let me just pull up the Monopoly board here. How do I open image in new tab? Okay, this is what we want. Okay, so whoa, stop. So you start here, and then you travel around, and if you land on go to jail, you get sent immediately to jail. In jail, there's two ways. You can be just visiting jail, okay, and then you can actually be in jail. So if you are at go and you roll 10, you will be just visiting jail, and you're not actually in jail at that moment. And so the next turn you can continue on. Okay, I don't know what's going on. And continue on and go to the Pennsylvania Railroad and whatnot. However, if you do something that the game says will send you to jail, then you are put in jail. So if you land on this spot, then the police officer sends you in jail, and you are locked in jail. Okay. And in the regular game of Monopoly, you have the choice of paying $50 bail to get out of jail, or maybe you have a get out of jail free card, or you can just wait another turn. Okay. And you can wait up to 3 turns, and on the 3rd turn, you are kicked out of jail no matter what. So if you pay $50, you get out of jail. If you use your get out of jail free card, you get out of jail. Or if you by chance roll doubles being like 2-2, 3-3, 4-4, anything where you get the same number on both dies, you get out of jail. Okay. But if you don't pay the fine and you roll and you get something like 4-6, okay, then you stay in jail, and you can stay up to 3 turns in jail. On the 3rd turn, you get kicked out of jail. Okay, and if you play the game, the general strategy is in the beginning while there's still properties to buy, you want to get out of jail as quickly as you can so you can buy properties. Later on, when all the board is filled up, like everybody has bought all the properties, then it's actually beneficial to remain in jail because at least you're not being charged rent. And we're not going to try to implement any kind of strategy in our game, and we're just going to say, you know what, we're going to just remain in jail as long as we can. Okay, when you roll doubles, you get to take another turn, but if you roll doubles 3 times in a row, on your 3rd time, you get immediately sent to jail. You don't go to that spot, you get immediately sent to jail. Okay, we have 2 decks of cards, the Chance and the Community Chest deck. These are special spots on the boards. Wherever you see the question mark, you draw from the Chance deck, and anytime you see one of these blue chests, you draw from the Community Chest deck, and each of these cards do different things. Chance will frequently move you around to other places on the board, and the Community Chest will often give you money. But there's a few things where Community Chest will send you to jail or send you to go, things like that. So you have to take into account, because the goal of this simulation is just to find out which spots are landed on most frequently and which ones are landed upon least frequently. So we're not trying to keep track of money or make any kind of Monopoly strategy game playing thing. That would be a lot more complicated. All we're trying to do is just see, which spots get landed upon most frequently. So with the Chance deck, you'd have to keep track of where they end up moving you around the board and keeping track of things that way. Okay, and here it talks about jail. And so as far as the simulation goes, if you choose to do the assignment, we would simulate 1,000 games, 1,000 2-player games that last 150 turns. So games truly last until somebody runs completely out of money, which is which I don't know how long that lasts, but here I'm going to just say is 150 turns. Maybe it's more, maybe it's less. And here we're going to say we're going to do 1,000 different games of 150 turns. Okay. So as far as the game goes, okay, I've set up the game board. Okay, we're going to set up a game board deck, a Community Chest deck, and where is it? The Chance deck. Okay. And so if I check out game board, okay, here there's 40 spots, and these are all listed from Go, Mediterranean Avenue, Community Chest, so on and so forth. Okay, so the way I strongly would approach this game is by creating a reference class a series of reference classes, okay? So where is my getting started example? We'll take a look at this. Okay. Here I've created a function called dice, and I've also created a manual dice, okay? And this is just so for the purpose of testing things out, okay? You know, I see a lot of questions on Piazza, and a lot of these questions, I think, I don't know, maybe we need to have like a day spent on debugging, although debugging is such a broad topic, okay? But the general idea you've got to take when trying to debug your code is break it down into one line at a time, okay? Make sure each line, if you run one line, make sure that one line does exactly what you expect it to do, okay? And a lot of times on Piazza, I see people write, kind of post out their error messages or their warnings or whatever. And to me, what it appears like is people started just writing a loop, and then they run the loop and it doesn't work, and they're like, why doesn't it work, okay? That's not a good way to go, all right? Before you run the loop, write one iteration and test out that iteration, okay? If you're gonna put it inside a loop, then before you run the loop, or if the loop's not running the way you want, if you got like a for I and 1 through 100, somewhere, don't run the loop, just run each line inside the thing, but just somewhere in your global environment set I equal to 1, okay? And then you can run inside the loop because you probably subset things based on bracket sub I or something like that. And then you can run each line inside that loop and just see, is it working the way I expect when I is equal to 1? And if it does, then increment to I equals 2, okay? And if that works, then your loop will probably work for I equal to 1 through 100. I have a feeling, though, whenever I see these errors and these warning messages, that if you just set I equal to 1 in your global environment and you try to run the lines in your loop line by line, something is probably breaking, something probably doesn't work. And so, when you try to run an entire loop and you try to debug the entire loop all at once, nobody's that good to be able to keep track of 10 lines of code in their head or 20 lines of code in their head and know exactly the relationship between each one. But we can do is one line at a time, okay? Another thing I also see is people with crazy, crazy, crazy if statements. It'll be like if parentheses, and it'll be like x sub 1 equals x sub 22, vertical bar, or x sub 55 equal x sub 67, I don't know, it's like a chain of like 30 if logical statements in one if bracket, okay? And then it doesn't work. Of course it's not. Like, you've made it too complicated. And it could be, one of those things could just be a typo, okay? Or like, it could just, make the true false thing that goes inside your if as simple as possible, okay? And it should always be true, it should always be false, it can never be NA. I don't know. So if you need to do all sorts of ands and ors and all of things like that, okay, do that outside of the if, and break them down into one piece at a time. If you need like this and this, then do that outside the loop up here, and see if and then you can break it down piece by piece and just make sure all of those things, okay? If you need a whole bunch of ands, then just have all these logical things and throw them into an all, okay? But anyway, let's, as far as this thing goes, the goal is to keep track of our spaces, and in order to do that, we need to have players run, okay? And so here I'm going to start off by creating a very, very basic reference class for our player. And here, so if you recall in object-oriented programming, reference classes are used to have objects that are mutable, meaning functions and other things can modify that object, okay? Whereas, most everything else in R is you kind of just copy, you copy the object. Here we have kind of reference class semantics here, okay? And so I started off by just having two fields, which is, one field is really just the position that the player is on the board, okay? Because we want to keep track of where each player is. And then I have a verbose option, which basically is going to say if it's verbose, okay? Verbose is going to be true or false. So if it's verbose, it's going to just output a bunch of stuff onto the screen so that I'm able to kind of diagnose what's going on, right? So if the during kind of debugging mode and just testing to make sure that this thing is behaving the way I want it to behave, I want the computer to output a whole bunch of stuff for me, okay? What you want to do is you want to expand your player reference class to include other things to keep track of, right? So if you imagine playing Monopoly yourself, and what are the things you have to keep track of? You got to keep track of your money, you got to keep track of your properties. We're not going to bother with that, okay? But you got to keep track of whether you are in jail or not, right? So that's going to be a field that you want to add to your reference class. Am I in jail? Okay. You want to keep track, how many turns have I spent in jail, right? Because on the third turn you get kicked out, right? So you need to keep track, right? So you need to keep track, what turn am I in jail, right? So you name that something like jail turns or something. You want to keep track of how many times you've rolled doubles, okay? Other stuff like that, okay? There are different fields that you want to keep track of inside your player reference class. And then the only way we should be updating the fields in our player reference class is via methods, okay? And because this all exists within a kind of its own environment, the methods will use super assignment to change the values inside the environment here. And so here we're going to just say move n spaces, and all it's going to do is take our current position and add n to them and update the position in the player environment as such. So if we're at space 10 and we roll a 6, we're going to add 6 to that, and we're going to be at space 16, okay? And here I just said, but double check, if we've gone past 40, right? So 40 is boardwalk, and let's say I'm at 41, which means I've ended up back at go, then I need to just subtract off 40 because we're going in a circle. So that's all I'm doing, okay? And I just said if it's verbose, then you're going to start off by saying player's at this position, player's going to move n spaces, and after you've done the update, you're going to say player's now at this position. Okay, I've created another method which is going to be used for things like drawing the chance cards. So if you draw a chance card and it says like go to space 12, okay, go to go or something, space 1, then we can just take that spot and put it into position. Yes?
What exactly is verbose? Will it ever not be verbose?
So verbose is just a true or false, okay? So when you create your player, you can say I want a verbose player or I don't want a verbose player, okay? So in the creation of a player, if the character trait for verbose is set to false, then it will not print any of this, it will not cat any of this stuff onto the screen. It's just going to update the positions, and it will just do these commands silently. Yeah, so a lot of times, because frequently in debugging, what we will do is you'll put in all of these print statements, and then you will comment them on and comment them off, right? And you're like, wait, it's working. Okay, now I'm gonna comment all of these print statements out, and then I'm going to go on. And then later on, you're like, oh no, it's not working. I got to throw all of these print statements back in, right? So to kind of avoid that process of having to turn on the print statements and turn them off, all I'm doing, I'm just replacing that with a true/false up here called verbose, okay? And basically, if it's verbose, it turns on the print statements, and if it's not verbose, it's not going to do those print statements, okay? So it handles a very common and useful thing that we do when we're debugging, which is printing out information for us that's useful to make sure that things are working the way we want it to be working, right? Okay, so that's what I have here. If it's verbose, then print all of this stuff out. But when it's working, and I don't, like, when you're actually doing like the 1,000 simulations, you don't want all of this information flying by on the screen, right? It's like when you're just testing your code out. So that's what we have, okay? And then so here I'm going to just create 2 new players, okay? Player 1 is from player reference class. We're going to use the new method, and we're going to start off at go, and we're going to say it's true. Player 2 is another creation of the player reference class. Start at go, verbose is true. Okay, so we do that. Okay, over here I'm going to create a reference class called tracking, and this is going to be basically a tally, a way to keep track of where everybody has landed. Okay, so if you have landed at Mediterranean Avenue, you will put a tally at Mediterranean Avenue, okay? And so basically, there's only one field called tally, okay? And this is going to be a vector of 40 values, one for each spot on the board. And then there's only one method here, which is increase count, okay? And we're going to just say increase the count on spot n. So all we're going to do is just say find, in tally, find spot n, and add 1 to it and increase the count at that tally, okay? And that's it, okay? But this is just so we can keep track of everybody, and that's really all we need for the tracking class, okay? And so here I'm going to create an object called space tracking, and that creates our tracking system here. Okay. All right, and then here is taking a turn. This has not implemented any rules whatsoever. In taking a turn, we're going to call the dice command, okay? And the dice function, as I have it written, is just the dice is just going to sample 1 through 6 twice with replacement, okay? And it's going to return back a list of the faces, the doubles, and the movement, okay? If the 2 faces are equal, it's going to return doubles as true, otherwise doubles will be false, and the movement is going to be the sum of those faces. So every time I call dice, it's going to just return kind of the faces I rolled, 2, 4. I did not get doubles, movement is 6, okay? So basically, for taking a turn, here I roll the dice. It says I'm going to move the movement, okay? And then I'm going to increase the count in tracking and at the player position, okay? And that's it. And so that's the most basic. We haven't implemented any rules other than roll the dice, move that much, and add a tally there. And so we can just kind of try this out. So I'll say take a turn for player 1, space tracking. So because we're doing reference class, normally whenever you call a function, you have to like capture the output of that function, right? But with take turn, I mean not with take turn, with reference classes, all we have to do is we just call the method, and it's going to update things internally. So it's a little bit different. And so take turn takes in 2 arguments, an object of player class and an object of tracking class. It's not even specified, just a player and a tracking object. And then it's going to, so here we're going to do it for player 1 and here for space tracking. These are turned to verbose. So I did player at 1, player moves 5, player is now at 6. Okay, we'll try player 2. Player 2's also at go. Player 2 rolls player's at 1, player moves 10, player's now at 11. Okay, and then we can just check the space tracking class. Okay, so space tracking is just that vector of 40 values starting off all at zeros, and we can see that it has indeed increased the count at 6 and has increased the count at 11. Okay, and in here we can kind of just see, you know, the status for player 1. Player 1 is at position 6 and verbose is true. You know what? If I wanted to, I think it might make sense. So if let's do tracking tally is numeric, and I'll do a verbose equals logical. And increase count, and we'll just do if verbose cat add a tally at n. Okay. So we'll do that, and then so now I'm creating a space tracking that's a verbose space tracking, okay? And so let's just kind of see this, right? So now it says player at 6, player moves 5, player now at 11, add a tally at 11, okay, so on and so forth. Player at 11, player moves 10, player now at 21, add a tally at 21, so on and so forth, okay? And we can keep doing this, add a tally at 19, add a tally at 31, and we can ask for our space tracking object, and we can see that we have indeed added tallies at those locations. Add a tally at 31, and we can see that we did, and we get field that the verbose is true. So I don't know. So something like that could be useful in terms of trying to debug and making sure that you are counting tallies where you're supposed to be counting tallies. Okay, so here I'm going to just try a simple simulation of 100 games. So here, again, we haven't implemented any rules other than just rolling dice and running around the board. So after many simulations, we would expect a near uniform distribution, right, on the spaces, because we're just running around in circles. So I'm going to just reset my space tracking, and I'm going to run 100 games. And so this is what I mean. If you write a loop like this, and it's not doing what you want, don't just try to fix something and then run the entire loop again, okay? Well, you want to, if it's not working, just say I is equal to 1, all right? And then work inside this loop and just see if the thing is working correctly, okay? I should probably use a different letter there, okay? So here it says for I in 1 through 100, we're gonna just create a thing that says a new game I. Player 1 is this. We're creating a new player, okay? And then inside that new game, we're gonna have 150 turns, and we just say we're gonna have all of this going here. Okay, so here I have verbose set to false, okay? But maybe I'll just set it to true in the beginning, but not do 150 turns. Okay, maybe I'll just do 10 turns, and we'll just do 5 games. Okay, so I'll go ahead and I'll run this. Oops. Added. Oh, because I changed the specification of space tracking, right? So let's do space tracking verbose equals true, because I changed the specification of space tracking. So let's just see this. Set C does that. Get that. Okay, so here is so this is a lot of output just for 5 games of 10 turns, right? So we can see new game 1, players at 1, we add a tally at 6, player 2's turn, we add a tally at 11, so on and so forth, okay? And then finally, we're gonna just end that, new game 2. this is all in the same space tracking thing, and so at the very end of this, we can kind of just see space underscore tracking, and we have, this is what we have after a whole bunch of turns, okay? Let me just redo this, and we're going to set verbose equal to false here. Verbose is false, and verbose is false here. And I'll do 100 games, and we'll do 150 turns for each of these, okay? So you can imagine if I were to do this with verbose, it would just be, oh, as it is, and I probably should have commented this thing out, cat new game there. Okay, so we did 150 turns, and I can ask for space tracking here. All right, and we can see this looks pretty bar plot. We can just kind of see how this looks. So it looks pretty uniform, right? And that's kind of what we would expect because we haven't really implemented any rules so far. So it does look fairly uniform, okay? When you have something complex, right? So what you would want to do is you'd want to just add to the player reference class, okay, a little by little to add a new feature that you're going to try to keep track of. And then for something like this, where you're rolling dice, it can be very frustrating to have to like wait for the randomness to do the random thing you want it to do, right? Like, one of the rules is if you're in jail and you roll doubles, you get out. But if you're in jail and you don't roll doubles, you have to stay there, right? How are you going to test this out? You have to if you're depending on the randomness, you have to wait for the computer to randomly enter jail or get sent to jail, and then you have to wait for the computer to randomly either roll doubles or randomly not roll doubles, okay? Something like that can be very frustrating to do. So to test this, you might want to have something like a series of manual dice rolls, okay, that you can then alter and force certain game conditions to happen, right? So in real actual dice, it's very unlikely to roll 3 doubles in a row. But when you set the dice yourself, you can, if you are playing the god of the dice, you can do this. And so to do this, the way we can implement some manual dice rolls is I've created a reference class called dice, okay? And the dice reference class has a vector called rolls and a value called position and an option called logical. And basically, you have a vector of rolls here. And what it's going to do is it's going to return back 2 values in that vector of rolls. And then it's going to move to the next position. So what we have is I have a vector that goes 6, 4, 5, 3, 3, 5, 6, 2. And the first time you call the dice, oops, I don't know what just happened here. Okay. Here I'm going to just set a dice function to be the we're going to call the roll method on dice. Okay, and so what this looks like is if I call dice, it's going to return back 6, 4. If I call dice again, it's going to return back 5, 3. And then if I call dice again, it will return back the next 2 in the vector, 3, 5. If I call dice again, it will return 6, 2. If I call dice again, it will return 5, 4. Okay? And so this way, you can set it up so that you can probably illegally, like if you want to see, like if I land on spot 31, okay, which is go to jail. Well, I get sent to jail. You could just do 30, 0, right? There's no dice face that has a 30, but you could do this, and and the first time you roll dice, it's going to send you to do a movement of 30, and it will send you to that go to jail spot, okay? And then you can see, does my character player end up in jail after rolling that? And then you can kind of, and after doing that, you can say, okay, if I get sent to jail, so this move should send me to jail, then we'll try rolling doubles to see if we get out of jail, right? And so you can set the dice this way and just see, okay, let's call dice, we get sent to jail, whoops, and let's see if we roll doubles to get out, right? And so somewhere inside take turn, you could just do player move n, and then you'll say if player $ position is equal to 31, then we'll do player $ go to jail, okay? And so maybe we'll create a method inside the player called go to jail. It's going to be a function. Doesn't matter, right? And it's going to just be position will be updated to the jail spot, and then if verbose cat player is in jail. Okay. This is probably not enough, but this is just to kind of demonstrate how this might work. So I'm going to fix my taking turn. We'll define a new set our dice here. Okay, all right, and then let's just see if this works, right? So we'll do, we'll just do player 1. Okay, so it says, so indeed, we did take turn for player 1. It says we rolled a 30, player's at 1, player moves 30, player now at 31. And then it updates and says player is in jail, so that's good. And then I'm getting an error that says, if verbose. So my space tracking class didn't have the verbose thing set. But you can, when you're testing out your code, this is how you would do it. You would set the dice manually and try things out kind of incrementally for each feature, all right? Don't just program everything and then say, all right, let's see if it works, and then it doesn't, right? One thing at a time, make sure it works completely, then move on to the next thing. All right, we'll end there. Good luck.